Good day. My assigned topic is application of integral 6.3 volume with rings, example number 3. So, determine the volume of the solid obtained by rotating the region bounded by y equals x squared minus 2x and y is equal x about the line y is equal to 4. Solution. First, let's get the bounding region and the solid graph. Again, we are going to be looking for the volume of the walls of this object. Also, since we are rotating about a horizontal axis, we know that the cross-sectional area will be a function of x. Here are a couple of sketches of the boundaries of the walls of this object, as well as a typical ring. The sketch on the left include the back portion of the object to give a little context to the figure on the right. Now, we're going to have to be careful here in determining the inner and the outer radius, as they aren't going to be quite as simply they were in the previous two examples. So, let's start with the inner radius, as this one is a little clearer. First, the inner radius is not x. The distance from the x-axis to the inner edge of the ring is x, but we want the radius, and that is the distance from the axis of rotation to the inner edge of the ring. So, we know that the distance from the axis of rotation to the x-axis is 4, and the distance from the inner ring is x. The inner radius must then be the difference between these two, or inner radius is equal to 4 minus x. The outer radius works the same way. The outer radius is outer radius 4 minus the quantity of x squared minus 2x is equal to the quantity of negative x squared plus 2x plus 4. Note that given the location of the typical ring in the sketch, above the formula for the outer radius may not look quite right, but it is in fact correct. As sketched, the outer edge of the ring is below the x-axis, and at this point the value of the function will be negative, and so when we do the subtraction in the formula for the outer radius, we'll actually be subtracting off a negative number, which has the net effect of adding this distance onto 4, and that gives the correct outer radius. Likewise, if the outer edge is above the x-axis, the function value will be positive, and so we'll be doing an honest subtraction. Here and again, we'll get the correct radius in this case. The cross-sectional area for this case is a sub x is equal to pi, the quantity of negative x squared plus 2x plus 4 raised to the power of 2 minus 4 minus x squared is equal to the pi, the quantity of x raised to the power of 4 minus 4 x cubed minus 5x squared plus 24x. So, that's all on my topic.